Hey, welcome back to your favorite Math 126E class. You guys are going to take a look at algebra today, simplifying. If you want to go ahead and read that first paragraph to yourself, that'd be great. All right, so that being said, after you read that paragraph, let's take a look at this first example here. In the expression 5x plus 8, let's identify how many terms you have. So there's one term, there's another term. They're separated by a plus or a minus. So we have two terms here, right? Our variable part is that x, right? That's our variable in this expression. And then the numerical coefficient. So see the 5x there? That's our coefficient, the number in front of the variable there. So that's our coefficient, is the 5. And what's our constant term? Well, our constant term is just our number, right? The number portion. There's no variable involved with it. So the 8 is our constant term. And then the next question, is there any like terms? Like we can combine like terms. For example, 2a and 3a. They both have the same variable, a, and they have the same power of the variable. So we can combine those. If I have 2 apples and 3 apples, I can add and get 5 apples, right? So those are like terms. But 2a squared and 3a are not like terms. You cannot add those. So again, you got to have the same variable and power in order to add like terms or subtract like terms. Okay? Multiplication and division is different. You can multiply anything. But let's look at this next one. In the expression x plus 7 plus 2x, how many terms do we have? Hopefully you say, yeah, 3 terms. There's an x, 1, 2, and 3, right? Separated by plus. So 3 terms. Numerical coefficient of the first term. Well, our first term is that x right there. So what's the coefficient in front? It doesn't show it. Yeah, 1x, right? If there's nothing there, it's a 1. So there's our coefficient of that first term. And what's our constant term? Yeah, constant says 7 right there. And lastly, is there any like terms? Sure, the x and the 2x are like terms, so we could combine that, right? 1x plus 2x would be 3x. It's not asking us to combine them, but those are the like terms there. I'm going to have you guys do this last one. I'm going to make that a you try it problem. If you want to pause the video, you should see that as your solution to that you try it problem. All right, let's move into distributive property. Distributive property says a times b plus c equals a times b plus a times c. For example, like 2 times 3 plus 4. Well, we know 3 plus 4 is 7, right? So this ends up being 14. But let's see if this works, the distributive property on this. Well, that distributive property is saying I could go 2 times 3 plus 2 times 4, which is 6 plus 8. Oh yeah, they're both 14, right? So anyways, that's your distributive property. Probably remember that from middle school, high school. So let's go ahead and use it right here. We've got 5 times m plus 5 times 3. So we got 5m plus 15. I do want to simplify this, which just means combine any like terms. Do I have any like terms here? No, I got a constant, and then I got one with a variable, so nothing I can combine, right? Let's go ahead and do it for these next couple. I got 2 times 22y plus 2 times negative 3, so I got 44y plus a negative 6. I will simplify that. We know a positive times a negative is a negative, right? So we got 44y minus 6. We've got a fourth times that 12x plus a fourth times that 8. You could put that 12x over 1, right? So I got 12x times 1 is just a 12x. 4 times 1 is a 4. Over here, I've got 8 times 1 is 8, 4 times 1 is 4. So it looks like I got 3x, 12 divided by 4, plus 2. Go ahead and pause the video. You can try those next two. All right, if you want to check yourself on those U-try problems, pause the video, you're welcome to. Then we'll move into simplifying expressions by combining like terms. So if we're combining like terms, right, we're adding and subtracting. When we're adding and subtracting, we can only combine the ones, add and subtract the ones that are like terms, right? So they have to have the same variable, same power. So 6x cubed minus 4x cubed, I'm like, oh, they're both x cubed, right? So what's 6 minus 4? 2x cubed, right? 6 bananas minus 4 bananas is 2 bananas, right? X cubed being our bananas, whatever. So 4x squared minus 7x squared, are they like terms? Yeah, so 4 minus 7 is negative 3x squared on that. Let's go to another expression with like and some that are not like, right? Do we have any like terms? Hopefully you say, yeah, the 5y and the 3y are like terms. So 5y plus 3y gives us 8y plus our constant term plus the 2. Let's do this next one, then I'll let you guys try the last couple here, like terms. 6x, combine it with that. 3x gives us the 9x, and then notice the 7 minus 2, the constant terms are like terms. So we got minus 5. Oh, I'm sorry, plus 5. 7 minus 2 is a positive 5. Sorry about that. Now we've got an involved distributive property. So we want to go ahead and distribute it first, and then see if we can't combine some like terms. So we got 7 times 4x, so we got 28x. 7 times 11, I got 77. And then we got that minus 6 on the end. And just go ahead and combine those like terms. And go ahead and try this next one, and then you can pause it. Oh, so you got negative 4r plus 15 on that one. Let's get into translating phrases. So English phrases into algebra. Sum or more than means add. If you ever hear the word difference, right, that would be subtract. Product, multiply, quotient, divide, equal, or is equal. So let's look at this first example. Write the given statement out. So it says, let x represent the number, and here's the quote. The sum of, so we got a plus, 5 times a number and 9 times that number. We're going to let that number be x. The sum of 5 times the number and the other term being 9 times the number, right? And you say, well, if we can simplify it, go ahead and simplify it. We can simplify it. We do get 14x. Let's look at another one, this one down below. The product of 4 and a number. So product of 4 and a number, we don't know what the number is, we'll let it be the variable x. Product of 4 and a number, which is then subtracted from the product of 15 and the number. So it looks like we got negative 11x. Why don't you guys try the next one? Well, check your U-try problem there. Let's move into some exponents. If you recall from before, we said x times x times x times x can be rewritten shorthand notation with x to the 4th, right? Mathematicians are lazy, not in the fact that they are not hard workers. They're actually very hard workers, stereotypically. But they like to shorthand their notation. They want it very, very concise, right? And so mathematics is a language in and of itself. So there's the exponential language, right? X is the base, 4 is the exponent there. But let's go ahead and evaluate the expression using the exponential notation there. We got x squared when, and they're telling us what the x is. The x is negative 11. So let's just plug it in. Negative 11 times another negative 11 gives us 121. Let's do another one here. Now we've got an expression negative 10x plus y, where x is the 7, y is the 5. So it looks like here we've got negative 70 plus 5. So we've got negative 65 on that one. Why don't you guys go ahead and try those next two there, and we'll check it. All right, go ahead and check your work on that. Pause it if you need to. Thanks so much for watching. See you next time.